Hello students, I have sent you this worksheet yesterday and I hope you have attempted this worksheet, and now I'm trying to explain the questions. I'm not sure if I have enough time to explain two questions. Let me try. If not, I will send you another video for question 2, okay? So now basically for IR, this topic is seldom that only this topic will appear in the exam. Most likely it will combine with other knowledge and to become a non-question like that. So just like this one, okay? Now let us look at the questions together. Compound X with a relative molecular mass of this one has the following composition. When you see this composition, you know that the question is going to ask you to work out the empirical and the molecular formula. This is actually what we have learned in IG, right? Oh, compound X react with acidified potassium dichromate solution to give compound Y, okay? And when compound Y is tested with Tollens reagent, there is no observable change. So now for this one, you know that it should be a ketone, right? Because it's resistant to oxidation. And for this one, you know that it should be either primary or secondary alcohol, right? Because that is why it can be oxidized. Okay, determine the molecular formula. Okay, let's just work out the molecular formula together first. Now, remember to give proper presentation in the exam. Okay, you copy them. The percentage mass, you can consider them as the mass as well, right? Assuming you have 100 grams of the sample. Then you work out the mole, show the step. Remember, only divided by the molar mass of an atom. We are talking about atom. So some students, I found that you will times 2 with 16 because you think oxygen is molecule, but right now we are talking about atom. Oh, then we work out the answer together. So this is 5, this is this one, and this is this one. Okay, and then we will have a mole ratio. So this will be okay. So this will be like that. So this will be like, this is just the empirical formula. Remember, empirical formula will be C3H8O. Now, but you have to show the steps to work out the molecular formula first, because the molar mass is given 60, right? Can you see the molar mass is given? So what we can do is, same as what we did, we try to assume that it is C3NHNHANON. Then we try to find out N, okay? So the N will be equal to the molar mass divided by the empirical mass. So it will be 1. Therefore, the molecular formula will be C3H8O. Okay? Based on the infrared spectrum only, write 2 possible structural formula of compound X. Now, when you look at this, now this is what we have learned yesterday. It has a broad peak here, right? A broad peak, which we correspond to OH. OH, and then now here it doesn't have a sharp peak. So which means the original compound doesn't contain a carbonyl group. So now, when you look at the number of oxygen atom, it has only one O, right? And it doesn't contain any carbonyl group. So obviously it is an alcohol, right? So you can draw it out. Now remember to draw the hydrogen atom. So it will be like that, okay? Now for this one, if it is oxidized, it will become aldehyde, right? It will become aldehyde because your product contains only one oxygen, so it's impossible for it to become carboxylic acid. So it will become an aldehyde, then it will show positive result to Tollens reagent. But when you look at the question, there is no observable change when it is tested with Tollens reagent. So which means this one should not be the answer. So this one will be the answer. Remember to fill in the hydrogen. Okay, it's propane 2O. Okay, determine what compound X is. You can say you can write it out. It is first, you have to say that it is propane 2O, right? Because when propane 2O undergo oxidation, it will form ketone, right? Which shows no result on Toland's reagent that is consistent with the information given from the question. But if it is a primary alcohol, upon oxidation, the product that contains only one oxygen should be aldehyde. Then it will show positive result to Toland's reagent, which is not consistent with the information given from the question. So that will be this one, propane 2O, okay? So name compound Y after oxidation. We all know that this is compound Y, this is X, right? Name, so it's propanone. Any question? Propanone. 好, we still have some time. Let's just look at this one. Okay, molecular formula again. Let's just work it out. I try to write it here. Easier for me to copy the number. So it will be C6H10O1, okay? Now, since its relative molecular mass is between this one now, then you can let it be C6N H10N ON, right? So which is between 90 to 100. Then you just sum them up, 6N, 12, 10N1, 16N. So it will be 98. Now, you will see that n is between 0.92 and 1.02, and n has to be an integer, right? So therefore, n should be 1, which means the molecular formula is equal to the empirical formula for X. It will be C6H10O. C6H10O, okay? Oh, from the infrared spectrum, just one functional group present. Now, can you see there is no board peak here, so there is no hydroxide, hydroxyl group, sorry. Now, but there is a sharp peak here. It tells you it definitely has this one, right? So you can say, suggest one functional group is the carbonyl group. Deduce one possible structure. Now you have 6 carbon, right? So now if you think of it, if you do it like that, then you will have how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but you only have 10 hydrogen. And you look at this one as well. When it reacts with acidified potassium dichromate or bromine, no reaction, which means it doesn't contain a double bond, no double bond, right? No double bond, but you have to reduce the hydrogen from 12 to 10. The only way is it should not be a aliphatic structure. It is a wing structure. So it should be like that. Okay? That can help you to reduce the number of hydrogen without adding double bond on it. Now you can count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it's like that. That is the answer. Do you understand the logic? Because the question told you it doesn't react with bromine in the dark, which means it doesn't contain carbon-carbon double bond. But if it doesn't have any carbon-carbon double bond, and if it is a straight chain, it will contain 12 hydrogen. which is impossible because the question told you it only contains 10 hydrogen, right? So the only way is this structure exists as a ring structure. So that is the answer. So the answer will be like that. And it is called hexane cyclohexane. Okay? So that is the explanation for this one. I will make another video to explain the calculation, the mole question I gave you yesterday, okay? So watch this one first, but I hope you can do it first before you look at the explanation.